today I'm going to be talking about the central findings of the Leverage Introspection Program. For that, I'm going to bring up my screen in a second to talk through some of them, but these are actually now available on the internet. You can go to leverage.institute. This is our new website. And if you go to the social science section, you'll see that we have a summary of Leverage's introspection research. It's a PDF document that summarizes the findings. Before I go into the details, I wanted to talk a bit about some of the challenge involved in summarizing the findings, what has in fact been summarized, and where that will be filled in the future. Big challenge. So for background, Leverage ran an introspective psychology research program from 2012 to mid 2019. I had been doing introspective psychology research before that, and most notably ended up with a theory called connection theory in late 2008. And then after some experimentation with that, concluded that it was good enough to subject to wider tests. Ended up founding Leverage, not just for the sake of studying psychology, but for studying a bunch of different things. And then between 2012 and mid 2019, about half of our total effort went into the psychology research. So then there have been a whole bunch of calls for us to publish results. And we, for a while, weren't really focused on publishing because we were focused on discovery and investigation. We also had concerns about whether the things were safe to share with the public. Whenever one is making progress in science and technology, it's important to consider, is this going to be beneficial overall? Having thought about it, have concluded, we'll say we've got a tentative yes on this is great and worth sharing. But then there's the challenge of figuring out how exactly to present the material. I recently went through and mocked up what a description of some of it would look like. And the mock-up was about 200 pages worth. And I think that covered a third, maybe. And then it's just like there's just like such a very large amount of material. We had published previously explanations of the history of the program. We published a very, very high level overview, but we had never managed to figure out how to compose something that functioned as a good overview, essentially something that, if you think of it like a map, you might then want to zoom in on one or another section. As it so happened, over the last month, I guess, maybe it's a month or two now, I ended up producing a document that, in fact, is, as far as I can tell, happy to people note anything that is missing, but a document that covers, that is meant to be a map covering the material in an overview sort of way, such that if you want to know more, you could point to a particular area and say, tell me more about that. And then we could zoom in on that and fill in details, and then zoom in again and fill in more details. It actually was challenging to get to the point of being able to describe the results of the research in this way. One of the reasons for that, which is going to become clear as I go through this, is that we made a lot of progress. And so the claim here ends up being surprisingly large. Um, we think that that's fine because all of the things being stated here, one should not think of as settled science. Science is a process whereby many researchers engage in investigation. There are observations. The observations are shared. The scientific community engages in a practice of checking and correction. Um, we ourselves had something like that internally at Leverage between 2012 and 2019, but that is not in any way a stand-in for the scientific process overall. So what you can think of the things here as you could say they're conjectures, or you could call them hypotheses. It's more like this is a statement of or a summary of results or findings that we do expect other people will end up investigating, and we do expect will end up being confirmed. And if it turns out not 100% of things end up being confirmed, 90%, 80%, we'd be grateful for the correction. The goal is to, in this circumstance, we were attempting to advance human knowledge. All right. So with that as an overall description and a proviso, let me share my screen. All right. So here, and then again, people can find this on the summary of Leverage Introspection Research document at leverage.institute. But what I'm going to do now is I'm going to talk through the central findings, and these, it's broken down into 10. There, you could think of these as summaries of topics, though claims are embedded within them. And it could have been broken down into 20. It could have been broken down into some other number. This seems to me to be a good way to organize the material. As an overview, though, the device or the method or the mechanism that I found was a good way to summarize the findings involved an analogy to the physical sciences. And so people are familiar with physics and chemistry and biology and so forth. The claim here is that we ended up working out not just a physics of the mind, but the physics, the chemistry, the biology, and the ecology of the mind. Now that, I mean, as we'll see, many questions in each part remain to be answered. While there are many questions that remain to be answered, we think very substantial progress was made in such a way that it, we think, makes it possible or takes steps forward towards the existence of psychology as a science. And so, yes, we do think that this is a very big deal in thinking about how to talk about these. I've been wondering, should we publish, it's like if this is the summary version, should the full version come out in something like the Wolfram style new kind of science, 800 page, etc. document? So to start off, the first claim has to do with ontology. So many people may not have encountered the word ontology or will have encountered it tangentially. The ontology, I mean, the word actually comes from Greek, refers to the logic of being. But when people use the word, what they're talking about is what are the basic categories of existing things in a given theory. And so you might imagine a theory of the mind that refers to feelings and refers to thoughts. And then everything else gets broken down into feelings and thoughts. If you do that, then your ontology is feelings and thoughts. And then different theories of the mind will have different ontologies. Now, one thing in the summary document people can read online is I in that document describe a number of the different attempts to turn psychology into a science. People have been trying to do this for a while. There are a number of famous attempts. If you look at how the mind gets characterized in those different attempts, you'll find that there are different ontologies. Famously, with Freud, you end up with and I'm probably not actually going to be able to characterize it perfectly in terms of ontology, but you're looking at I mean, a much easier one's actually going to be structuralism. So structuralism was a attempt to turn psychology into a science by Wundt and Titchener, and they focused especially on perception and trying to break down sensory experience into all of its atoms. And so then whatever you would break it down into, that gives you the ontology. We found that the human mind can be adequately described using a small number of concepts. The concepts used include belief, concept. Uh, you could include the word representation, which is a category that includes beliefs and concepts. Also sensation, and awareness, and spatial relation. For the full, official description, you should see a more complete write-up, but that's a very, very small number of different concepts. And so the claim here is that something like that is going to be adequate for the description of the human mind. And I've grouped that here under physics because if you think about the physics of the world, if you think about, for example, under Newton, there you have mass is one of the basic things. You'll have gravitational force. So force is going to be one of the basic things, but there's only a small number of concepts, the vocabulary you need to state physics, and this stays true even as physics progresses past Newton. There's only a very limited vocabulary. So then we further found that most, and then question mark on all, but let's leave it at most for right now, of the human mind can be described with a few simple rules. So these rules ended up being included in connection theory. This was a theory of the mind that the Leverage team, I would say, it was there when Leverage was founded, but it took a couple years for the researchers to conclude that the descriptions given in the theory were actually good and seemed to match reality. Then, over the course of research, we ended up finding additional rules that should be added. So the rules, there's the belief rule, for example. The belief rule states that when people update their beliefs, they do so in a way that explains their experience or their sensations, that updates in the direction of elegance or trying to fit things together. Also, that does so in a way that is local rather than global, so that the elegance, it's not that the entire belief system is shifting towards elegance, but rather that some part of it is at any given time. And finally, that when a person's beliefs update, this happens under the constraint or restriction that the person always believes that their basic goals will end up being achieved. And so there you have explanation of sensation, local updating in the direction of elegance under the constraint that the person continues to believe the basic goals will be achieved. That is a description of belief updating. There are other rules like the action rule. The action rule says that people act in accordance with what they believe will happen. These were both rules that were originally part of the theory. The formulation of the action rule was made tighter, maybe in early 2014. I'd have to check. But we ended up adding other rules. We added the attention postulate, which says that people update where they pay attention. and also then that they do not update where they are not paying attention. Also, that the intention claim, where people's intention is part of their attention, so that if you intend something, then that is in some way included in your attention. These basic rules, and the reason I make the analogy to physics is that what happens in physics is you have a number of basic rules that are stated very abstractly. And then you want to know, okay, well, what ends up happening? You end up applying the basic rules in ways where a bunch of them combined produce some particular effect. So I just noted, for example, the belief rule and the attention postulate and intention claim. If you end up combining those, it's the intention claim says that the intention is part of the attention. The attention postulate says that people update where they pay attention. This means that people are always in some way paying attention to the content of their own intention. And then if you add the belief rule, people are always trying to fit together their experience with the beliefs that they're paying attention to, which has the implication that whenever people update, or sorry, whenever people have experiences, they always try to fit those experiences in with their current intention. And when I say try here, I don't mean as an action, I mean that the mind is automatically doing this. That ends up having a bunch of further implications, and happy to sort of go into that if that's of interest. So the thing that I just described was some content on the basic rules, and the basic rules are themselves phrased in terms of a simple ontology. I've analogized that to a physics. I wouldn't say that it was complete, and I'll talk about gaps and questions that need to still be answered in a little bit. But so then the mind as described by the different rules that I just stated, there's a question about what's going to be driving the dynamics overall. And this gets us to claim number 3. Claim number 3 is that there is a central factor in the mind that drives most of the mental dynamics. People think, are people rational or are they irrational? Are they mostly driven by feeling? Are they driven by reason? The claim here is that it's beliefs that are driving most of the mental dynamics. One would need to figure out how to characterize causes of emotions, but it's very plausible that emotions arise in a manner that is in accordance with beliefs, and then actions seem to come out of beliefs, and beliefs come out of beliefs. And so, beliefs come out of beliefs plus experience. But essentially what you have is you have belief as the central driver. This is important because what then ends up happening is that if you're going to study people's minds from the perspective laid out here, the thing you're ultimately going to be spending most of your time doing is trying to characterize a person's beliefs. Now, it so happens, here I'm transitioning to number 4, and this is where we get the analogy to chemistry. The beliefs, as our researchers found, end up forming in a fairly small number of recognizable forms. You can think of this as if beliefs are, in some sense, the most fundamental unit, then you want to know how those units end up combining. And if they end up combining in recognizable forms, then so long as those are then small inputs into much larger structures, then you might think about that as though that's a chemistry. Now, a full write-up would include and the document online mentions some of these, but would detail the different structures that we found. We found beliefs held in place by other beliefs in a chain. You could call those roots. We found cases where there were hundreds, of very, very similar beliefs on a given topic. And so a person might think that they're awesome, and also that they're great, and also that they are super, and also that, etc. And so you can have usually we were dealing with this in a negative context. The person would think that they were bad, and that people didn't like them, and that people hated them, and so forth. And in changing those beliefs, it's like you're hacking through a thicket. We ended up calling those structures thickets. There's roots, thickets. There were also gaps, zones, modes. We ended up with these names for the different structures. But the key thing is that the structures depend on or are composed of beliefs, and there's a small number of recognizable forms. So uh, just like in chemistry, where you have a small number of different components then add up to the chemical elements, which then add up to all of the compounds and all of the visible things that we see. We also saw a relatively small number of microstructures. The mind ends up being super, super complex. And so the one of the big challenges was figuring out how to actually investigate it such that you would be able to say something useful. We found that some parts, if you just go in, I mean, if we've got this idea that beliefs are the driver, if you just go in and try to map out the beliefs, you know, Oliver here, Oliver ran this experiment, ended up producing a graph with like 950 or some very, very large number of nodes. And it was clear that we had not begun to scratch the surface of the total number of beliefs. Beliefs just seem very, very hard if you want to map them all out. If beliefs then are driving the dynamics, you can see this creates a problem for studying the mind. Luckily, we found that some parts of belief systems are simple enough to be studied, and this bridges over to what one might think of as the biology. Now, the physics and the chemistry, these are things that one ends up looking at, but ends up looking at as part of looking at what I'm analogizing here to the biology. The biology here, the analog, or to translate out of the analogy, we're talking about studying individual people's minds. If the belief systems are too complicated or too complex, then, well, maybe there are other parts that can be studied. Because beliefs are driving the dynamics, these other parts will be made of beliefs, but they're not going to be the only things that they're made of beliefs, but they're not it's not just a sort of random selection of beliefs. We found that notably goal systems, especially the consciously accessible goals, parts of people's goal systems, were in fact simple enough to be studied. Here you might end up with a map with 100 nodes or 300 or maybe 900, but still something where you got a good enough synopsis. And so what we would do to study people's minds is we had this challenge of getting accurate reports of beliefs. Now, this is the big problem in psychological research if you're trying to build a belief goal model, or rather, let me back up. One of the challenges in studying the mind is, well, where is it? Okay, well, you have access to your mind in some sense, other people's minds, will you infer things about it? One of the easiest ways to get information about people's minds is they say something, like they say, I feel angry, or I feel happy. Maybe they say, I believe that so-and-so will win the election. Maybe they don't phrase it in terms of beliefs. They just say, so-and-so will win the election. We take those as indications of beliefs. And then when people act, it's a fairly simple heuristic to imagine that they're acting for the sake of achieving different goals. And so a person might have the belief that by reading a book, they will gain valuable knowledge. and have the goal of gaining valuable knowledge and have the belief that to read the book, they have to walk across the room to pick it up. And so they form the goal of walking across the room to pick up the book so that they can read it, so that they can get valuable knowledge. And then they actually take those actions. And you see the actions and you imagine the actions are coming from a set of beliefs and a set of goals. You can infer some information of that type from people's actions. You can also get information from people's statements. The statements, though, are not always accurate, not necessarily because someone's trying to mislead you, but they may not know, or they may be reporting in a way that does not match the underlying beliefs. One of the first things we ended up working on was a way to get much higher fidelity information, much more reliable reports of beliefs. Once you get reliable reports of beliefs, or sufficiently reliable, then you can build a much better belief goal map. And then if you go in some directions, you'll find too much complexity, too much complication. But if you go in other directions, you'll find that you can actually map the thing out. This is what a bunch of our researchers spent a very, very large amount of time doing, was building out maps of people's goals using reports, applying a filter designed to sort out what are likely to be the more accurate versus less accurate reports of beliefs. So then goal systems, you get these representations of goal systems. This is a part that can actually be studied, and then it turns out that the people will frequently report patterns of goals that seem surprising or unusual. So a person might have the goal of getting knowledge from a book, believe that to do so, they have to read it, pick up the book to read it, read for a minute, put the book down. They're not exactly sure why. They later remember they want to read this. They read for a minute. They put it back down again. Well, okay, something interesting is happening. It's more complicated. You might end up finding, for example, the person might have beliefs about how to efficiently use their time. And it might be that their beliefs stably switch back and forth between one state or mode where they believe they have lots of time and another state where they believe they don't have a lot of time. You could then imagine that you could then find, getting reports from the person, and there's various ways to check these things, that the person's beliefs update when they start reading. So they start off in the mode where they believe they have lots of time, and so they have time to read a book and learn. And then they pick up the book, and as they start reading, they then come to believe that they don't have time. And that they then form the new plan to read the book later. And so they close it and put it down. As you could imagine, someone who had this pair of sets of beliefs that they switched back and forth between, having the surprising behavior of opening the book and never really managing to get more than a page at a time. What I just described there was an example of what it would be to investigate some particular behavior and reports about the behavior, filtered so that you get the reports that are much more likely to be reliable. And then you end up with goal systems as well as representations of some of the different pockets of belief that impact the person's ways of pursuing their goals. All of that ended up being nicely finite, definitely like studyable. There were other things that ended up being studyable as well. If you don't try to go through and map out all of the beliefs on a sort of very large topic, but instead you just focus on, what does this person believe about God or believe about death? What do they believe about the future of technology? Family is an enormous topic, but you pick it precisely enough, whether their mother loves them. These are all topics that can be investigated. They're, again, nicely finite. And you can then investigate across different people and see what are the sorts of patterns that you end up coming to. Our researchers mostly did not do a lot of surveys of large numbers of people to investigate particular topics because they were mostly concerned with figuring out how you could induce change in different parts of the belief system. And this involved spending a lot of time looking at the chemistry and interacting with what I've been analogizing to the physics. Okay, but so the claim, though, is that the mind running on beliefs can be studied. Some parts are simple enough to be studied. These includes goal systems, beliefs on a bunch of different topics. I also have listed here causes of beliefs. That one's actually derivable out of the physics, so that ends up being easily studied. The next thing that we found, and so we spent a bunch of years. It was roughly 2012 to 2014 was essentially validating some of the research methods and in particular working out how to get the more reliable reports of beliefs. We developed a technique called belief reporting, which is a introspective technique that makes it possible to get much more reliable reports. And then spent 2015 through 2017 and through 2018 just mapping out tons and tons of different parts of people's minds, trying to figure out, like, it's like if you manage to actually get the stream of information from the mind and you figure out how to filter it so that you can get the reliable parts, then the thing you want to do is you want to interact with it as, and find all the patterns that you can. One of the things that we ended up finding was a belief structure. There are a couple of different ways this can be implemented, but there's a class of structure that we titled attentional redirects. This is where when a person goes to pay attention to something, their attention bounces off. This can be implemented by means of action. Sometimes there are topics where when a person goes to think about them, they will reflexively take a mental, so to speak, reflexively take a mental action where they distract themselves. There's a question about whether this can happen even without action. That depends on the pattern of attention, which is something on which we did not end up getting a final answer. But at the very least, we did encounter a large number of attentional redirects. These in the simplest case, the person loses track of the conversation or changes the topic, or even simpler, you ask them X and they answer on Y, but Y is pretty close to X, and so no one notices. Or unless you're paying close attention, then you ask them to answer on X and then they answer on Y again, and you're like, wait a second, something weird is happening. But we also found cases where people would become drowsy or fall asleep upon being asked questions. And we spent a bunch of time, especially in 2016 and 2017, trying to figure out what to do about the attentional redirects. We ended up with an answer. The answer involved looking at the possibility of nonverbal communication. We essentially, and this is described more in the document, the summary document, we ended up with methods that first seemed to allow people to track another person's attention non-verbally. So, person A has their eyes closed, person, has their hand on person B's shoulder and then tries to call out what person B's attention is doing. Our model of this is consistent essentially with micro movements on the part of person B being picked up by person A, who then introspects on themselves. It was very interesting to see that it looked like people could track other people's attention in this way. And then we found that it looked like people were able to actually read information off of one another in a way that seemed to be working non-verbally. We looked into this further. The research that we had done previously on the different structures, essentially physics and chemistry, and you could say the microbiology, made it so that we were already very familiar with what belief structures looked like. And so when we started looking at information derived from nonverbal communication, it was easy to correlate it. When you say easy, it was doable to correlate it to things that we had already seen, and it looked like the same pattern showed up. So then this led us to the conclusion that people are inundated with high bandwidth nonverbal communication. Most people believe that, by the way. They think that there's 90% of communication is nonverbal or something like that. People, anything that could be communicated by an actor through an expression could be communicated nonverbally. Tons of things can be communicated through context. That's generally believed, but I think people frequently think about it as though that sort of communication is fleeting. If you imagine, instead of it being that something's communicated and immediately lost, if you imagine that the nonverbal communication is being imprinted on people such that it leaves a trace. I mean, leaves, an entire imprint. And then they receive more nonverbal communication, and that leaves more information. Then you can think about it as though people are downloading from people around them a very large amount of information. Of course, we're not always aware of this, frequently not aware of this, but this fits in with the attentional redirects that we found. And so what we found was that people are, in fact, absorbing a very large amount of what you could think of as subconscious information. And then it's just, well, you think of it as subconscious because it's very, very hard for them to pay attention to. We did find, you could say, well, if it's hard to pay attention to, how do you know that it's happening? The answer is, well, we found methods to read the things off, and you could direct people's attention to the things frequently, and you could test changing it and seeing whether that would change people's behavior. There were lots of different things that we could do that we had learned from studying the more easily accessible aspects of the mind. And we ended up concluding that, in fact, the high bandwidth nonverbal communication is occurring. Different people have different theories about how it works. But then this makes all sorts of really surprising phenomena possible. The idea here is imagine that in the course of talking to someone, you're not just hearing the words, but you're downloading a lot more information about that's coming in from the person by means of a more subtle communication. Well, you think, okay, well, that means you get to know someone better by talking to them just than from the words. But you have to take into account that they have also been downloading information from other people. And then those people have been downloading information from other people. And we've been doing this our whole lives, which essentially means that there is an information bath that we exist in. And this makes it so that in principle, you could end up having really good intuitions about your friend's friend, even though you've never met your friend's friend and you only hear your friend describe them in one sentence. Some people will say, hey, wait, I have really good intuitions about my friend's friend. And then the question is, okay, how does that work? It's like, well, I'm a very intuitive person. It's like, yes, okay, but how does that work? And this provides a mechanism. This makes it so that you could say that it provides a mechanism for intuition. It also provides mechanisms for other surprising things. So serendipity synchronicity is going to be one of these. So Carl Jung talks about synchronicity. This is a circumstance or a phenomenon where people experience something at the same time. There's like surprising coincidences. Maybe you and a friend who haven't talked to each other in years both think of each other and think to call each other, and one does. The other says, that's amazing. I hadn't thought about you in a while, but I also had the same thought. That's very hard to explain if you are just referring to the conscious material in people's minds. But if you imagine that people are downloading this very thorough, textured, dense set of information packets about each other essentially all the time or very, very frequently, then what's happening is there's a lot going on unconsciously or subconsciously that might prompt both the people at the same time to think about one another. And so that gives the possibility of explaining a whole bunch of phenomena that actually are, at least antecedently, very surprising. I was personally very, very surprised. So then the picture that gets painted here is of people with minds, where the minds are constituted centrally by beliefs. You have a belief system. The belief systems are, the people are communicating with one another, and content from belief systems is essentially being copied or transferred. This is happening in accordance with a set of rules, and it really matters what you're paying attention to. This happens in a way that yields coherent goal structures for people, where those people always end up with ways that they are trying to achieve basic goals that they persistently believe they are going to achieve. And then that's all in the mind composed out of these much smaller structures that are repeated and copied in terms of structure and form all over the place. You're dealing with like a small number of basic structures. And again, then all of that is running according to rules. That is the big picture that we ended up with. This includes a bunch of different research methods, a useful thing to see, which I'm not going to talk about right now. I think I talked about it the last presentation, is looking to see how some of this stuff can be applied in a way that produces changes in a person's belief system, but it is possible to set up feedback loops. Essentially, you can get the ability to elicit belief and goal structures and then predict which changes are going to be caused from certain interventions, and then do those interventions and then see the results. And this gives you the ability to run a very, very large number of low-cost tests. And from there, you can then set about exploring the mind. The things that I described, if they end up being confirmed by other researchers, then we're going to see links to a whole bunch of different fields. There's links between this and physical health, for example. One thing we found is that people seem to have a body map or a mental map that corresponds to or relates to muscles. And then it ends up being possible to cause changes in a way that causes persistently tense muscles to relax. That's an application that relates to health. There's going to be applications that relate to group effectiveness. We ended up looking at, say a bunch of different things there. There's going to be applications at the sociological level. And I mean, this would not be very surprising. The mind is central. So if you figure out a lot more about how the mind works, you should expect to find things that end up relating to other fields. Even though I think we got really, really far, there were a bunch of questions that we didn't end up answering. Different researchers had different proposals. There were a couple of proposals for how the emotions work. This is occurring in a context where the emotions are going to be downstream of beliefs. That may be surprising. You might think missing the emotions is a big part. Well, if so, then it's a something that remains to be figured out. So there's an incentive, and maybe some of our researchers' theories will end up being right or maybe not. There was also a question about the pattern of attention that didn't end up getting answered. And those just pertain to the physics part. That's just like the basic rules. There was further questions like, did we end up getting all of the different basic belief structures? And then there are tons of questions about how people's minds actually work. It's possible, or how people's minds are actually currently constituted. You can take phenomena like teenage rebellion or religious belief and investigate and find the many different ways that those things can be implemented in the mind. We ended up coming across many of those topics, but did not end up pursuing them persistently. So there's just a very large amount that remains to be figured out. That's a presentation of the sort of overall arc. I guess if I had to repeat it again concisely, it would be that the mind has a simple ontology, that in the language of that ontology, the mind follows a small number of simple rules, that those simple rules, that the dynamics are centrally governed by beliefs, that beliefs form structures, and in particular, a small number of basic structures that then you can find in many, many different places in the mind. That those structures then constitute or compose or build up minds that are extraordinarily complex. I mentioned the conscious mind, the unconscious mind, or the parts that are hard to pay attention to seem like they are much, much larger and more complicated. But despite the complexity, there are parts that can be studied, in particular, the goal system and pockets of beliefs relating to the goal system. And that then it's possible to find people following all of the same dynamics are in fact engaged in high bandwidth nonverbal communication, such that the updates aren't just conscious, but there's things happening that are hard to pay attention to, and that those produce overall belief dynamics that yield a complex and surprising information environment in which people's minds are updating. That, I'd say, is a summary. I would propose that the way that people distinguish emotions from regular feelings, so, it's like you have like an itch in your foot or something. Let's say you're angry or you're happy or you're sad. In a lot of cases, so on the face of it, just looking at things at first glance, a lot of emotions have cognitive content. So it's not just that you're angry in general, you're angry at someone. And you might say, well, sometimes I just feel angry in general. So we could talk about that. But in a bunch of cases, you just have like anger at, the whatever, your anger at your friend, or you have sadness that, I don't know, missed your favorite show, like an easy example. And so in a lot of cases, if you were to take all the emotions, there are a whole bunch that just have representational features as part of the description. Emotions, the way you distinguish them is that they also have the feeling concept, the feeling component. And if you think of the feeling as a sensation, it's like you're sad and you have this feeling in your head or this feeling in your stomach, but also you are sad about something. Like, maybe you're, looking forward to seeing someone, but it turns out they can't visit, and so you're sad about that. Okay, well, you've got the feeling part, and then you've got the cognitive part. The cognitive part includes a representation of the world. So then there's a question of, are emotions a single type of thing, or are there subtypes, right? Because like sometimes it's very hard to identify, like, I just feel sad. Why are you sad? I don't know. I just feel sad. Some days I just feel sad. So if some emotions have readily identifiable cognitive components and other emotions don't, then there's a question, are there really two types of emotion, or is it really all one type? And if it's all really one type, then they've all got to have cognitive content, because some of them definitely have cognitive content. So then this would be something like the research program, or you could think of this as an argument, but it's more like a direction of research. It's some emotions have cognitive content. The emotions seem like they're actually one type of thing. Can we find the cognitive content where you're just feeling sad and you don't know why, and maybe there is no why, But then you belief report a bunch and you're like, oh, yeah, no, I'm sad about this. And it makes sense that I'm sad about this. And you find the cognitive content. But if you can find cognitive content attached to emotions, then the evolutionary story you described, where you start off with sensations and then you get emotions and then you get cognition, that can't be the right story because cognition's occurring at the same time as emotions. I think that if you look back at the sort of evolutionary hierarchy, there are certain things that show up at certain points, and then there's a question of why did they show up? A really interesting one is computation. So humans can engage in computation in the sense of like a universal Turing machine, in the sense of can execute a computer program steps one at a time. Um, that's interesting. I currently suspect that, well, at least we're the only species that is demonstrated to be able to do that. It's an interesting question whether any of the other species could be trained easily to do that. But that's something that shows up at a certain point. You also get, sort of like advanced society and whatnot showing up at a certain point. So then I think there's this great question of when do the things first show up? I uh, and so I've been looking into this in part because I've been studying quantum biology, but it turns out that the human senses, a bunch of them are very, very sensitive. So like eyes can pick up single photons. There's at least models on which, the ears can pick up things happening at the relevant level. And so looking at the quantum bio area, there's this question, are the senses in some way running on quantum? But if the senses are, then there's the next question is a question about sense fusion. So it's like you have sensory inputs from your eyes and your ears, those get combined. Okay, so if we call that sense fusion, there was sensory fusion, then there's a question about that, and then cognition and computation and so forth. And so I'd love to know which of these, like when each of these things show up. My guess is that the my guess is cognition shows up super early. But notably, these things can all be investigated. It's easiest to investigate in humans, and then you want to work out like what are the patterns in the emotions? Do all relevantly similar feelings have associated cognitive content? Um, if so, that's very interesting. And then what's the pattern? And then going back and looking through the evolutionary descent tree and then seeing where things maybe came in, I think that's a fantastic research project. Okay, so that was item number one. That was emotions. Item number two was asking about evolution. And so the first thing to note is that in some cases you end up with puzzles. Like you develop two different areas of science and you're not sure how they fit, and then you sit there for a while and try to get them to fit. We have this with quantum physics and general relativity. That said, it'd be nice if your stuff fits. Do you think the brain is an evolved organ? And so then, and it also seems like it has these different modules. If the brain looks like it has different modules, then how do you explain having a theory that of how beliefs function that does not have itself have corresponding modules? I think that's a great question. I think the link to neuroscience is extremely valuable to investigate. One thing is that it's actually really hard to investigate the neuroscience of the mind if you don't have a good baseline theory of how the mind works. It's like you can sit there and look at, neurons X, Y, and Z fired, and the person also reported seeing a red patch. But if you don't have a good characterization of what's happening in the person's mind overall, if you're at the level, you're at the primitive level of sees a red patch, then it's going to be quite hard to identify neural correlates. I think identifying neural correlates, yep, that's a fantastic activity. And one can do that if or one can start to do that. So you like map out somebody's goal structure. And then then there is a question about how you're going to get relevant information about the brain. There's this cool project Forest Neurotech that's working on ultrasound as a way of imaging the brain. Um, I think, yeah, so good questions there. I think there are a whole bunch of questions here that are sort of hard to answer. So one is just, even, put aside this particular view of the mind and just think about computation. I think it's really interesting to think about how you can get how evolution can produce something that's capable of computation. The You wouldn't expect an evolutionary process, for example, to produce something like your Intel chipset, or maybe your NVIDIA GPU, or whatever the state of the art is. I do think evolution is at work, but the people have largely assumed that the only driver can be evolution. And so like a lot of weight gets put on the evolutionary part as a driver. A different thing, apart from quantum bio, that I've been looking into is Wolfram's stuff. So we also have this on the new Leverage website. People should check it out, leverage.institute, where we've got a nice concise summary of Wolfram's research. Essentially, there are a bunch of some very simple discrete systems that produce complexity of certain types. I think when you're looking at the macro structure of the brain, and the sort of folding pattern, that seems very, very reminiscent of stuff that can be produced easily by cellular automata. So that it strikes me as though some of the explanation of the brain is going to come through the discrete sort of Wolfram style explanation. But if you sort of take and add all these things together, it's like I think quantum biology, essentially, there's a very, very strong case that there is a underappreciated magnetic to quantum mechanism at work in biology, including the brain. There's the discrete systems Wolfram mechanism. And then I'm not sure how any of that reliably adds up to a goal-directed process. If evolution ends up being a strong optimizer, then, and maybe this is, so I've sort of wound my way through many, many topics, but maybe I can give a concise answer now. It depends how strong of an optimizer you think evolution is. If evolution is a strong optimizer, then the answer might just be that, well, this was a, simpler and easier mechanism and it was more effective, so it got selected for, and that's why we have it. If you think that evolution is a weak optimizer, then you've got a whole lot of stuff you need to explain in addition to the, simple patterns of belief updating. You also have to explain goal directedness just in general. You have to explain the human ability to do computation. And so I think that schematically, maybe we could say there's like a middle area where evolution is strong enough optimizer to make things pretty efficient, but not so efficient that it makes it so that, so that you'd end up with something as simple as the rules that we ended up working with. Yeah, that's interesting. I think that's interesting. My guess is evolution's a weak optimizer and that we need to bring in like 4 or 5 different causal explanations in order to really explain what's happening in the brain. Basically, I think that, so I am very partial to mind style explanations. There is a particular amazing possibility that I'm still trying to think through, especially in light of the Wolfram stuff, that actually comes from Kant and the Critique of Pure Reason, where Kant is, I'm going to summarize this. Kant proposes that the mind is more fundamental than the physical world, that space and time are essentially our lenses, and that all the things that we sense, we then lay out in space and time. He also thinks that the mind's processing adds causation so that you end up with uh, you end up with physics the way that it is because of the way the mind is processing the information. Notably, in his description of how you might reconcile free will with universal causality, he proposes that minds might will something, like they might will the good or the bad or something else. And in so doing, you have a whole bunch of minds with different wills, and you could imagine that then they all appear to each other as occurring in a spatial and temporal universe that is governed by causality, but set up with initial conditions that allow them each to appear in a world in a way that accords, that reflects the quality of their own will. And so it's like the person who wills, in a uh, meek manner versus a person who wills in a bold manner ends up showing up as a meek person or a bold person at some point in the total universal history. I think that's extremely cool. Whether that ends up being correct or not, that is an extremely interesting explanation. And then you can imagine a more general idea, which is what happens if the physical world ends up being in some way a reflection of you could think, I don't have good words to describe this yet, but it's like, what if the physical world is the digital representation of minds that themselves run on something else, like concepts? I think that's great. I think that's fair game as a possibility. The challenge, and this is something that I'm in fact working on now, may take a little while. Um, I think that a lot of these explanations, while they're cool, work best when you understand their limits. So, like the question, for example, of is quantum physics involved in some way in human cognition? This is like, is the mind a quantum computer? Well, the mind's not a quantum computer like the one Google, whatever, announced today. Those sorts of quantum computers work at very, very low temperatures, and they have very, very different features than the human mind. Maybe if we get quantum computers like those actually working, then they'll be able to factor really large numbers into primes and do it super fast. That's not something the human mind seems to be particularly good at. Maybe we'll surprise ourselves, but it doesn't seem like it. So it seems like the mind is not quantum computer of that type. But if you have quantumness occurring at the level of senses and at the level of sense fusion, and if sensory fusion is involved in cognition, you could imagine a view where rather than quantum sensitivity evolving after the fact, you actually have very early stage quantum sensitivity that then ends up getting preserved over the course of evolution with a strong constraint that anything that cuts off sensory or cognitive abilities ends up detracting from fitness in a way that essentially makes this into a hard constraint. I don't know if I explained this clearly, but there's a very different evolution works classically and sometimes evolves quantum sensitivity versus evolution starts off trying to preserve a particular quantum functionality, and then the things that evolve are ones that operate classically but preserve again that functionality. If something like that is happening, then it's much more likely that human cognition ends up being in some way related to quantum physics. And then I think that just exploring all of these things requires understanding them really well. So it's like people who like evolution will say that evolution is a strong optimizer. People who like, mind will say, well, maybe it's all mind. And people who like quantum will say maybe it's all quantum. I think we could actually get the answer. And for that, we have to understand the limits, like what the explanations can explain, and then where they run out. It's interesting because various spiritual interpretations are possible of the nonverbal communication stuff. There, I think that what scientists should do is they should figure out which sorts of things can be verified by means of observation and experiment, and sort of start there, and then not make overly, dismissive or overly confirming or disconfirming claims otherwise. And then we can progress towards figuring out more and more of what's happening in a way that is grounded in observation. I would note as a philosophical point that one can conceive causation apart from space and time. When thinking about causation, then the question is, can you imagine or conceive something causing something else without it including a concept of space or without including a concept of time? In traditional conceptions, like let's take like Aquinas's conception of God, for example. God is not spatial, and then can cause to exist minds. And so, Descartes has us think of this world where maybe all there is, maybe that's the most easy reference. It's imagine a world where there's nothing apart from an evil demon deceiving you into believing that there is a real physical world, right? So it's like you're in the Matrix, but there's no matrix, there's no robots, there's no power plant, there's just your mind. And so when you dream, and when you're awake, you're sort of dreaming. I think that that's a thing you can conceive, and you could conceive that even when the relevant evil entity causing this is itself just a mind. So I think that's something that's conceivable. That takes out the spatial element from the conception. And then for the temporal element, let me say this, I'll say it a different way. There's a notion of necessitation that shows up in logic. So if you think about the steps in a mathematical proof, where you have, A, and you have if A, then B, the logical proof, you have A, and then you have if A, then B, and you derive B. The truth of B is necessitated by the truth of A, and if A, then B. But that's not something that's happening in time, right? Even though we in time take time to look down the proof, the facts are all there all at once, and they have an implication that implies a conclusion at the same time. And the notion of causation you can take to be the notion of the necessitation of existence or the necessitation of being. And then because necessitation can be understood from implication without time, you there have a concept for causation without either space or time. With all these things, there is an unavoidable, can you actually think the thought? Does it actually make sense? There's a famous example that's used to try to illustrate the idea of a cause and effect that's not occurring in time, which is a foot sitting inside of a footprint. It's like the foot is the cause of the footprint, but they're both there at the same time, right? And for
Yeah,
various reasons, I don't like that example. But that example, some people will find evocative. I prefer to look at the fact that something that is the essence of causation or necessitation in particular is happening in a logical proof, and that's neither spatial nor temporal. See, it turned out that philosophy was useful. See, we knew it. We knew that philosophy was useful. It just so happens that you have to take the philosophy, use it to clarify your concepts, and then use that to investigate all of the cool hypotheses that are being investigated in the world, and then you can like combine them and or find out that they don't combine. I'm very interested to return to this question of I think there's sensing, there's sense fusion. Aristotle would have called that the common sense. There's cognition, there's computation, there's teleology, and there's consciousness. And I think when people think about the mind, they like to jumble these all up together and say, and then that it's better to separate them and think about whether they're related. But I think that the I'm this is what I'm thinking about now when I walk around outside. So I'm trying to figure out how you're going to get something that appears that is at least apparently superficially teleological, where teleological means goal directed. From all the research that we did that I talked about earlier, I don't think it's just a superficial appearance. I think people's actions are in fact goal-directed in a way that is quite robust upon examination, robust to perturbation. You sit there and mess around with belief structures and the goal-directedness stays. So I think goal-directedness is a thing that's going to need to be explained. And then I think, yeah, this is why I need to think about it more. There, I think the optimization power from evolution is quite helpful. You can have it be that something ends up surviving because it's better fit to survive. It has various characteristics. That doesn't tell you how the goal directedness is actually implemented. I mean, so I direct readers to the summary of Wolfram's research on our website. The Wolfram has this very useful concept. Essentially, what's happening is he's doing an empirical study of computer programs and their outputs, and ends up finding that there are a couple different types of outputs, and then it ends up being very hard to get. And I'll say again, yeah, this is the cutting edge. This is just in terms of
Yeah.
where I'm thinking about it. There's like deep learning programs, for example, like you can train your Go system to be very good at playing Go or very good at playing chess. And then that is apparently teleological. That's happening inside of a very simple system, though. There's like only a very small number of different so it's like teleology is going to be much easier there. There's a question of the degree to which goal directedness actually gets preserved in non-limited environments. And I realize the thing I'm saying here is not super clear, but it is advancing my thought one further step. Anyway, there's more to be figured out here. One of the interesting questions is, what are the goals that are discovered if one looks into the mind and elicits goal structures? And we found that a lot of stuff seems to tap out in universal flourishing and universal connection, which sounds very utopian. But then when you look at different traditions and they talk about, trying to reunite with the universe, or everyone, the individuality being overcome, there are at least certain connections or relations that could be drawn there. All right, excellent. Well, thanks everybody. Again, check this out, Leverage website, got leverage.institute, summary of Leverage's introspection research, central findings, and we will have more to follow.